So you all have been working on working with radicals. And so today I wanted to get on here and go over and do some examples and just help give a little bit more supportive information as far as how you go about multiplying square roots, how we go about dividing square roots, and just kind of give you some support on that. And then I also wanted to go over just kind of working with those radicals. In the next video I will post, I'll go over solving quadratic equations by factoring and then using the square root property. So let's just go ahead and start out with our section 9.2. So our section 9.2 is going to be looking at multiplying those square roots. So when we start talking about multiplying square roots, is where we need to remember a couple of our key rules. So number one is going to be that if A and B are non-negative, real numbers, then I can take the square root of A times the square root of B, and I can put that all underneath one radical sign. And this gives me more options and flexibility as being able to break this down further, be able to simplify it by being able to take some numbers out from underneath the square root sign. So another key thing to remember is that if underneath the square root sign, if a variable is raised to an even power, we can simply divide that power by 2, so basically divide it in half, and it moves it to the outside of the radical sign. Okay, when we're working at simplifying it. So let's go ahead and start taking a look at a couple of our examples. First of all, if we have the square root of 7 times the square root of 2. These are both going to be non-negative numbers. And they're both prime numbers, which means we're not going to be able to pull anything out of the root. So in order to simplify this, we'll multiply 7 times 2 and give us the square root of 14. And that's as simplified as we can get it. Now, if we have options to be able to simplify it more, that's what we always want to look at. So if I have the square root of 12, then I'm going to simplify it by breaking it down into 4 times 3. And I know that 4 is 2 squared times 3. So I'm going to divide this exponent by 2, which gives me 1, which tells me I can take a 2 to the power of 1 outside and leave the square root of 3 on the inside. So my final answer is going to be 2 square root of 3. So when we start looking at the quotient rule or doing some division with things, we also have some rules when we're dividing. And the first thing is that if A and B are again non-negative real numbers, and B is not equal to 0, then when we have the square root of A over B, we can just break that into the square root of A over the square root of B, and we can manipulate it from there. Now, we don't ever want to have a radical in the denominator. That is not the most simplified form. So we're going to have to manipulate to get that radical out of the denominator. So To do one that is a pretty simple example, if we have the square root of 9 divided by the square root of 25, we know that 9 is 3 squared, and we know that 25 is 5 squared. So we can simplify this to be 3 over 5. So we don't have to do any work in order to pull out that, get rid of the root sign in the denominator. Another example would be if we have the situation where we have, let's just do 45 times the square root of 56 divided by 9 times the square root of 8. So the very first thing you always want to look to do and see is, can we simplify what is outside of the root sign? Which we can. We can divide 9 evenly into 45 5 times, so we can rewrite this as 5 the square root of 56 over the square root of 8, because we have canceled out this 9 and this 45 became 5. The next thing we want to do is see, is there a way to get a square root of 8 out of the square root of 56 to be able to simplify it? So we want to go ahead and, I would say over to the side, factor our 56. And if we remember that if we take 8 times 7 gives us 56. So what I'm going to do here is I'm going to rewrite this as 5 the square root of 8 times the square root of 7, because I can break those square root signs up if we remember back to our multiplication. We can keep it all underneath the one root sign, or we can simplify it into two different root signs. And now I see that I have a square root of 8 on the top, a square root of 8 on the bottom. I can cancel those square roots out. They become 1, and I am left with 5 the square root of 7. Anytime you're wanting to simplify your square roots, you always want to make sure that you are stepping through step by step. So if we have an example like this, where we have the square root of 12 times the square root of 3. What I would start out by doing is I would get this 12 factored down. We know 2 times 6 equals 12, but we have a 3 under here, so I want to see if I have something that I can give me 2 3s. So I know that 4 times 3 gives me 12. So I'm going to rewrite all of this under one radical sign. So I have 4 times 3 times 3. I can take this one step further and write it as 2 times 2, which will give me my 4, times 3 times 3. I now can pull out a 2 and a 3, so that will give me 2 times 3, or 6 will be my simplified radical for this. When you start having more complex things, such as with our variables, we're going to go through the same exact thing. So if I have the example of, let's just do the square root of y to the 8th power divided by 169. This is an even exponent, so if I divide by 2, I get 4, so I can pop the y out and it'll be y to the 4th. And I can look and I know that 169 is 13 times 13. So I can take that out of the square root, which gives me a 13. So that's how we go about multiplying and simplifying out our radicals. Now, as I said earlier, we do not want to have a radical in the bottom of our, in the denominator. So when we're dividing by radicals, we need to make sure that we take that out. So let's go ahead and take a look at how we go about rationalizing a denominator, or getting rid of that radical sign. So if I have the example of 1 over the square root of 7, I need to get rid of this radical sign from the bottom. And just like everything else, what we can do is multiply times the square root of 7 over the square root of 7. This number right here, if we look, is the same thing, is equal to 1, correct? Because we know that anything over itself is always going to be 1. So when we do that, we can now multiply 1 times the square root of 7 will put us the square root of 7 on the top. The square root of 7 times the square root of 7 will get rid of that radical sign and leave us with a 7. This is how we go about rationalizing that denominator. Now, if we have a case where we have x over x minus the square root of y, we have to make sure that we get rid of this square root of y. But we can't simply multiply by the square root of y because this is going to be a binomial. There's two terms right here. So what I'm going to have to do is I'm going to have to multiply this, and I'll use a dot instead of an x, times x plus the square root of y over x plus the square root of y. So I always want to use the opposite sign of what is in the denominator. And the reason for that is I want to be able to make sure I don't end up with a middle term. So when I multiply this out, I will multiply x times x gives me an x squared, plus x times the square root of y gives me x square root of y, all divided by, I'm now going to FOIL this. So if these are in parentheses, I'm going to go through my FOIL process. So I have x squared, then I have plus x times the square root of y, minus x times the square root of y, minus y. My middle terms are going to cancel out, and that is going to leave me with x squared plus x, the square root of y, divided by x squared minus y. And there is nothing else I can do to simplify that further. So that is going to be my end answer. So when you want to get rid of those denominators, you're always going to have to multiply it out. I hope this helps. Remember, if you have any questions, please reach out and I am more than happy to help you. Have a great day.